Okay, now we're looking at systems of equations. And we're going to solve this by graphing. This is chapter graphing, solving systems by graphing. So a system is two or more of something working together. A system of equations is two or more equations. If these equations are graphed, they almost always cross at some point. But when will these two lines not cross? When they are parallel. The crossing point is called a point of intersection. The point of intersection is the solution to the two equations. The solution is a unique x and a unique y that satisfy or that work in both equations. We can find the solution by graphing them and taking note of where they cross. So here we go. Let's try this. Find the solution of the following systems by graphing on the grids provided. So let's do the top one here. Your slope, my m, is going to be 1 over 3. Now remember that it's a rise and it's a run, rise over run, and it's positive, so we're heading up. And it's a positive 3, so we're going to the right. They're both positive. And so when they're positive, that means we go up, and that means we go right. Negative will mean going down, or it could mean going left, depending on where the negative sign is. And then we also have a starting point, and that starting point is our b value. It's our y-intercept, and it's happening at a positive 1. So I can look at my graph here, and there is 1. So I went up 1. This is the y-axis. And so I cross the y-axis. My y-intercept is here at 1. And then I can go up 1, 3 to the right, and put a little dot. Up 1, 3 to the right. Up 1, 3 to the right. And we want to keep with that pattern, but going backwards. So I'll go down 1, 3 to the left. Down 1, 3 to the left. Down 1, 3 to the left. And so now we need to connect those dots. Okay, so there's our line, and now we need to do the second equation. So here we have our slope, our m, for this thing. Now the slope is 2, but I'm going to write it 2 over 1. And remember, 2 is our rise, and it's a positive number, so we're going to rise up. And run is 1, and it's a positive 1, so we're going to go right. And we have a starting value, b here. Our y-intercept is 6. So look, there's 6 on the y right there. So I will do 6, and I can now start from 6. I can go rise up 2 over 1, up 2 over 1, down 2, 1 to the left, down 2, 1 to the left. I'm going to scroll down here. Down 2, 1 to the left, down 2, 1 to the left, down 2, 1 to the left. See, just keep going. I'll stop there. There's so many of these lines. And now all I have to do is connect the dots. Okay, so here we have it. This is the spot where these things cross. So this is our solution. And that solution is an x and y coordinate. And so let's see, what is that? 1, 2, 3. It's negative 3. So that point, now remember, all points have an x and a y direction. And so that point is negative 3 in the x direction and up 0. So that is our solution. Now, oh, I have a spot for that up here. Negative 3, comma, 0. So what does that actually mean? And so we're not going to do this here. Like, you're not going to be required to do this, but I'm just going to do this right now. Take this first equation, y equals a third x plus 1. And now this is an x and a y. So the y is 0, so I'll make the y 0. And the x is a negative 3. So equals a third times x plus 1. So I input the y and I input the x. Now negative 3 times a third. 3 and 3 can cancel out. So really this is 0 equals 1 and it's negative. So negative 1 plus 1. and negative 1 plus 1 is 0. So 0 equals 0. That is a true statement. So if you take this point and plug it into this equation, you're going to get a true statement. That point is on the line. But we can also put it in the other equation. So 2x plus 6. 2x plus 6. Y is 0. So I'll put that. And the x is negative 3. So equals 2 times the x, which is negative 3, plus 6. 0 equals 2 times negative 3 is negative 6 plus the 6. And negative 6 plus 6 is 0. That also works. So this point is on this line as well. So this is a really unique point in that it is on both lines and it makes a true statement. If we take this answer and put it into both of these, they get true statements. So that's it. That's what we're doing here. Let's find out which point can get us 2 true statements, a true statement for each. Let's start with the top one here, and we can have a slope. Now our slope is negative 4, which I'm going to do over 1. Now that's our rise. Now because it's a negative number, that means we're going to rise down. And then we have a run here. Now it's a positive 1, so we're going to go right. And of course our b value here is a negative 5. So let's start here at negative 5. Okay, so it's numbered for us, which is nice. So down here, that's our, remember this is our y-intercept. So down here is that we cross the y-axis. Sorry, it's not the y-intercept, it's the y-axis. But our y-intercept here is at negative 5. So we cross the y-axis at negative 5. And then we have to go down 4, 1 to the right. So down 4, 1 to the right. Okay, if I do any more, I'm moving off the graph. So I'm going to go to the opposite. I'm going to go up 4, 1 to the left. Up 4, 1 to the left. And then I'll keep going here. Up 4, 1 to the left. And the other one would go off the graph. So there's our points. Well, this is all just getting a little glitchy here. And I can now connect the dots, so hold on. Okay, so there we have it. I just connected the dots here. Now what do we need to do? The second equation. Okay, so the second equation here has a slope. Our m is negative 1 over 2. Notice I put the negative up to the top. That's generally what we do. So, and we can make it a little more obvious. Now, because it's a negative, that's our rise. Because it's negative, we're going to head down. And then we have our run here. Now, because it's positive, we're going to go right. So down 1, 2 to the right. And we have a starting spot of a positive 2. So on the y-axis, we'll cross at positive 2. So here's the y-axis. There's 2. And I will have a slope of down 1, 2 to the right. 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 Now let's go backwards. Go up 1, 2 to the left. Oh, look, there's where we cross. Up 1, 2 to the left. Up 1, 2 to the left. Up 1, 2 to the left. That should be good. So let me just now connect these dots. Okay, so we do have a point of intersection. It's right there. Now that point is in the x direction, negative 2, and in the y direction, up 3. So negative 2, 3. Now, we could, and we're not going to, but I'm just going to do this here. You could put this into the equation, y equals negative 4x minus 5, and you could put the x in. Now my x is negative 2, so negative 4 times negative 2 minus 5, and the y is 3. 3 equals, now negative 4 times negative 2 is a positive 8. 8 minus 5, now 8 minus 5 is 3, and this side is still 3, so 3 equals 3. This is a true statement. So if I take the point, put it into the equation, I get a true statement. That means this point is on the line. But this point should also be on the other line, which makes it really unique. The same point works for the other equation. And we could quickly just go negative a half times x plus 2. So negative a half times x, now x is negative 2, plus 2, and then the y is a 3. So the 2's can cancel here, so you've got a negative 1 times a negative, which is going to be a positive 1, plus 2. And 1 plus 2 you can see is 3, and the left side is still 3. So yes, you do get a true statement. You're never going to be required to do that. That's just me showing you now that yes, this actually works. This point is on both lines, but you can already see that it's on both lines because we just did a drawing and we drew this point at negative 2, 3 on both lines. So that's it for this video. We're going to do some more practice with this. You have to be very confident in graphing lines where you have a slope and a y-intercept, but other than that, it's relatively straightforward.